stray transients are voltage spikes that can occur in electrical systems. They are especially prevalent when there are overhead lines in the vicinity. These voltage spikes can potentially damage sensitive electronic equipment or lead to other electrical issues. In areas where overhead lines are abundant, utilizing metal conduit and electrical enclosures plays a crucial role in safeguarding against these stray transients. Electrical metallic tubing, often referred to as the EMT, and metal electrical boxes offer a conductive pathway for stray transients. This pathway effectively diverts the transients away from sensitive circuits, thus mitigating the risk of damage. A UL-listed electric chase ensures that the conduit and boxes adhere to stringent safety standards. It provides the required level of protection against electrical hazards. The recommendation for a vertical H configuration by the electrical inspector could pertain to the grounding path established for the sunroom. A grounding H typically comprises a vertical ground rod. This rod is connected to the main electrical panel and then extended horizontally to the sunroom's electrical system. Aluminum itself is a non-conductive material. This implies that it does not offer a path for stray transients to dissipate. Therefore, installing EMT and electrical boxes inside the sunroom becomes essential. It guarantees a proper grounding path. It also enhances protection against stray transients. The electrical inspector's guidance to install the EMT conduit and boxes within the UL-listed electric chase and vertical H appears to be a prudent measure. This measure is designed to shield against stray transients originating from nearby overhead lines. This is especially useful even if the sunroom is constructed from aluminum. This setup ensures a well-defined grounding path. It minimizes the potential for electrical problems arising from stray transients. When dealing with electrical installations, particularly in environments prone to voltage spikes, understanding the purpose and implementation of grounding and shielding techniques is paramount. Electrical metallic tubing, or EMT, serves as a crucial component in safeguarding electrical systems from various hazards. Its primary function extends beyond merely encasing wires. EMT provides a robust shield against electromagnetic interference, ME, and radio frequency interference, RFI, as well as offering a dedicated path for grounding, mitigating the risks associated with short circuits and stray currents. The use of EMT in metal enclosures creates what is known as a Faraday cage effect. This effect essentially diverts electrical noise and transient voltages away from sensitive electronic components, thereby enhancing their operational reliability and longevity. Furthermore, the grounding H configuration, as mentioned by the electrical inspector, is a critical aspect of ensuring electrical safety within the sunroom. By establishing a direct connection to earth ground, this configuration facilitates the safe dissipation of fault current. This minimizes the potential for electric shock and equipment damage. Aluminum, while being a lightweight and corrosion-resistant material commonly used in construction, does not inherently provide the necessary electrical conductivity for grounding purposes. Therefore, relying solely on the aluminum structure of the sunroom for grounding would be insufficient and potentially hazardous. The installation of EMT conduit and electrical boxes within the sunroom, as advised by the electrical inspector, effectively addresses this deficiency. It establishes a reliable grounding path that is independent of the aluminum structure. In addition to the practical benefits of using EMT and proper grounding techniques, adherence to electrical codes and standards is of utmost importance. These codes and standards, such as those set forth by the National Electrical Code, NEC, provide comprehensive guidelines for safe and effective electrical installations. Compliance with these regulations ensures that the electrical system is designed and installed in a manner that minimizes risks and maximizes performance. When considering the selection of EMT conduit and electrical boxes, it is essential to choose products that are specifically listed and labeled by underwriters' laboratories. All UL listing indicates that the products have been rigorously tested and evaluated to meet established safety standards. It provides assurance that the products are suitable for their intended purpose and will perform reliably under various operating conditions. The proper installation of EMT conduit and electrical boxes requires careful attention to detail and adherence to industry best practices. Firstly, the conduit must be securely fastened to the structure using appropriate fittings and supports. Secondly, all connections must be made tightly and properly grounded to ensure a continuous electrical path. Thirdly, the electrical boxes must be adequately sized to accommodate the wiring and devices they contain. Finally, the entire system must be inspected and tested to verify its integrity and functionality. Furthermore, it is important to consider the specific environmental conditions in which the electrical system will be operating. For instance, in areas with high humidity or exposure to corrosive substances, it may be necessary to use corrosion-resistant EMT conduit and electrical boxes to prevent premature failure and ensure long-term reliability. Additionally, in areas with extreme temperatures, it may be necessary to use specialized fittings and connectors that are designed to withstand the effects of thermal expansion and contraction. In summary, the electrical inspector's recommendation to install EMT conduit and electrical boxes within the UL-listed electric chase and vertical H is a well-founded approach to mitigating the risks associated with stray transients and ensuring electrical safety within the aluminum sunroom. By implementing these measures, one can create a safe and reliable electrical system that is protected against voltage spikes, electromagnetic interference, and other electrical hazards. Furthermore, it is essential to emphasize the importance of consulting with a qualified electrician or electrical engineer when designing and installing electrical systems. These professionals possess the knowledge and expertise to assess the specific needs of the application and recommend the most appropriate solutions. They can also ensure that the installation complies with all applicable codes and standards. Firstly, grounding ensures a safe path for electrical current in case of a fault. Secondly, shielding protects sensitive electronics from electromagnetic interference. Thirdly, proper conduit installation prevents physical damage to wiring. Fourthly, UL listing ensures products meet safety standards. Fifthly, regular inspections help maintain system integrity. Sixthly, surge protection devices can further mitigate transient voltage risks. Seventhly, using appropriately sized conductors prevents overheating. Eighthly, proper wire termination ensures reliable connections. Ninthly, compliance with NEC guidelines is essential for safety. Tenthly, professional installation guarantees proper execution. When dealing with electrical systems, understanding the specific types of transients and their potential sources is crucial for implementing effective protection measures. Transients can originate from various sources, including lightning strikes, switching of inductive loads, and electrostatic discharge, ESD. Each type of transient presents unique challenges and requires tailored protection strategies. Lightning strikes, for instance, can induce extremely high voltage surges that can propagate through electrical systems, causing widespread damage. Surge protection devices, SPDs, are specifically designed to divert these surges to ground, preventing them from reaching sensitive equipment. Switching of inductive loads, such as motors and transformers, can generate transient voltages due to the sudden interruption of current flow. These transients can be mitigated by using surge suppressors or snubber circuits, which absorb the excess energy and prevent voltage spikes. Electrostatic discharge (ESD) can occur when there is a buildup of static electricity on surfaces or objects. When a charged object comes into contact with an electronic device, the static electricity can discharge rapidly, causing damage to sensitive components. ESD protection measures include the use of anti-static mats, wrist straps, and air ionizers, which help to dissipate static electricity and prevent it from accumulating. In addition to addressing the specific sources of transients, it is also important to consider the overall grounding and bonding of the electrical system. Proper grounding and bonding provide a low impedance path for fault currents and transient voltages to return to the source, minimizing the potential for voltage differences between different parts of the system. This is particularly important in buildings with multiple electrical panels or interconnected systems. The grounding electrode system should be designed and installed in accordance with the NEC requirements, including the use of ground rods, ground plates, and underground metallic water pipes as grounding electrodes. The bonding conductor should be sized appropriately to handle the maximum fault current that could occur in the system. Furthermore, it is important to consider the potential for electromagnetic interference (EMI) and radio frequency interference (RFI) in the electrical system. EMI and RFI can disrupt the operation of electronic devices and cause data corruption. Shielded cables, filters, and enclosures can be used to mitigate EMI and RFI. Shielded cables have a conductive layer that surrounds the conductors, preventing electromagnetic fields from radiating outwards. Filters are used to attenuate unwanted frequencies in the electrical signal. Enclosures are used to shield electronic devices from external electromagnetic fields. Regular maintenance and inspection of the electrical system are essential for ensuring its continued safety and reliability. The grounding system should be inspected periodically to verify that it is still intact and functioning properly. The surge protection devices should be checked to ensure that they are still capable of providing protection. The wiring and connections should be inspected for signs of damage or deterioration. Any issues that are identified should be addressed promptly to prevent them from escalating into more serious problems. In conclusion, protecting electrical systems from transients and interference requires a comprehensive approach that addresses the specific sources of these disturbances and implements appropriate mitigation measures. Proper grounding, bonding, shielding, and surge protection are all essential components of a robust electrical system that can withstand the challenges of modern electronic equipment. Consulting with a qualified electrician or electrical engineer is crucial for designing and installing an electrical system that meets the specific needs of the application and complies with all applicable codes and standards. Remember to always prioritize safety when working with electricity and to seek professional assistance when needed. Stray voltage, also known as contact voltage, is a phenomenon where unwanted electrical potential exists between two conductive objects that should ideally have no voltage difference. This can occur in various environments, including agricultural settings, residential buildings, and industrial facilities. Stray voltage can pose a safety hazard to humans and animals, as it can cause electric shock or discomfort. Furthermore, it can disrupt the operation of sensitive electronic equipment. The causes of stray voltage are diverse and can include faulty wiring, improper grounding, imbalances in electrical distribution systems, and inductive coupling from nearby power lines. In agricultural settings, stray voltage can be particularly problematic, as it can affect livestock and crop production. Dairy cows, for example, are highly sensitive to stray voltage, and even small amounts of voltage can reduce their milk production and overall health. To mitigate the risks associated with stray voltage, it is essential to implement proper grounding and bonding techniques. Grounding provides a low impedance path for fault currents to return to the source, minimizing the potential for voltage differences between conductive objects. Bonding ensures that all metallic objects in the vicinity are electrically connected, preventing voltage differences from developing between them. Regular inspections and testing of the electrical system are crucial for identifying and addressing potential sources of stray voltage. Voltage measurements can be taken between various conductive objects to determine if any stray voltage is present. If stray voltage is detected, it is important to investigate the cause and implement corrective measures. These measures may include repairing faulty wiring, improving grounding and bonding, and balancing the electrical distribution system. In addition to the technical aspects of stray voltage mitigation, it is also important to educate people about the risks and how to identify and report potential problems. Training programs can be conducted for electricians, farmers, and other individuals who work with electrical systems. These programs can cover topics such as grounding and bonding techniques, voltage measurement procedures, and safety precautions. By raising awareness and providing practical training, it is possible to reduce the incidence of stray voltage and protect people and animals from its harmful effects. In conclusion, stray voltage is a complex and potentially hazardous phenomenon that requires a multifaceted approach to mitigation. Proper grounding, bonding, regular inspections, and public education are all essential components of a comprehensive stray voltage management program. By working together, electrical professionals, engineers, and community members can create safer and more reliable electrical environments for everyone. Finally, ensure there is a regular check on the grounding system so it is still intact and working properly, and also making sure that the surge protection devices are checked to ensure that they are still capable of providing protection.